Hey everyone, welcome to a new CODEBOX video. So in this third video of the series, we will see how to use for loops. In order to show how for loops work in CODEBOX, we are going to create a simple blur filter, which will simply blur our image. So let's start from scratch. This is my patch. As you can see, I've just created an empty jit.gen. I attached to it a movie player object, and there is this message radius. Now, if I double click on the jit.gen object, the gen patcher opens, and we are going to actually start from scratch. So, as we did in the past few videos, we are going to create a variable and call it final color and assign it to the input 1, and then we are simply going to pass it to the output 1. So the input 1, let's repeat, is the one that comes from the first inlet of the CODEBOX object, and output 1 is the output relative to the first outlet of the CODEBOX object. And they are connected to the first input of the jit.gen and to the first output of the jit.gen object. Good. So let's first see what a for loop is. So for loops are the way we got in programming to repeat tasks a certain amount of times. Now, when we work in Gen with graphical objects, we don't have any way to create for loops. So that's another advantage of CODEBOX, is that it allows us to work with for loops inside the Gen. So that's pretty cool. Let's see, for example, a for loop example. Let's create a variable and call it alternative output. And we're going to simply assign it to an empty vector. So a vector with 4 times 0. So if we pass it to the output, it's just going to be black, right? Good. Now let's create a for loop. Now, to create a for loop in most programming languages, including Gen, it works like this. We write for, we open parentheses, and now in Gen we don't have to write the type of the variables, so we will just create a variable, call it I, for example. This is a common name for the loop variable. And we say I is equal to 0, so we start by initializing this variable with a number, let's say 0. Then we say until I is less than a certain number, for example 3. It will execute everything that happens inside the for loop. So until I is less than 3, the for loop is going to be executed. Then we say as I plus equal to 1. So we're going to increment I of 1 unit. So it works like this. I starts by being equal to 0. We do what's inside the for loop until I is still less than 3, and we increment I of 1 unit at every cycle of the for loop. So everything that is inside this graph parentheses will happen until I is less than 3. So in this case, it will happen 3 times, because the first time I is going to be equal to 0, the second time I is going to be equal to 1, and the third time I is going to be equal to 2, and the fourth time I is going to be equal to 3, which is not less than 3, so the fourth iteration is not going to be executed. So will be executed 3 times. So now let's say alternative output. Inside the for loop, alternative output, we sum it to a vector full of i's. So we simply create a vector with 4 components, which are all I, so the value of I. So the first time, as we said, I is going to be equal to 0. Let's actually write it down. The second time, I is going to be equal to 1. Third time, I is going to be equal to 2. The fourth time, I is going to be equal to 3, and this doesn't get executed because the condition here is that I must be less than 3. So this doesn't get executed. Good. Now, if with the jit cell block we go to check what's inside this matrix that has been output, maybe you can already start to guess what this number is going to be. Of course, it's going to be 255 because we are working with the chars. So let's actually transform this into float32 by using jit matrix for 32. Let's just cap the dimensions to 320 by 240. Good. So we can see that the variable is that the number that is being output by jit.gen is now 3. If we say that the condition is that I must be less than 2, then the number will be 1. Because at the first round I will be equal to 0, so we sum alternative output plus equal to 0. The second round I will be equal to 1, so we assign alternative output to itself plus 1. But if we say 3, we are basically summing alternative output to itself, which was already 1 plus 2, because I is now equal to 2. That's why we get out a 3. Great. So let's now make something a bit more useful. I will actually just comment out those lines, so I keep it here as a reference. And let's create another for loop. So we say for I equal to 0, I less than 3, I plus equal to 1. In Gen, we cannot write I plus plus, like in another other lot of programming languages. This doesn't work in Gen. We have to write I plus equal to 1. So, and in this time, inside the for loop, we will sample the video at a different pixel every time. So let's do it like this. Final color plus equal. We're going to use the sample function this time because we want to have a bit of interpolation. So we are not going to use the nearest function. The sample function will give us a little interpolation. So we want to sample in 1 using the normalized coordinates plus a certain offset, which we will calculate using I for the x and 0 for the y. If we do that, I is an integer coordinate, this sample accepts actually normalized coordinates, so actually we should use sample pix, because sample pix will accept integer coordinates. So let's see if this works. Let's output final color. Oh, and we should actually, instead of using norm, we should use cell, as we said, because we are using integer coordinates exactly. So as you can see, the output is very bright because it's summing together the different pixels sampled at 1 pixel distance on the x-axis. So we should actually say final color divided equal to 3. So we should divide the output by 3 because we are summing together the pixels 3 times. So in order to have it back to basically 1, we should divide it by 3. Actually, we are doing it 4 times because we are assigning at the beginning final color equal to 1. So actually, we don't want to do that. Let's assign final color simply to an empty vector. Very well, so now the numbers are correct in the range 0 to 1 again. We can of course change the number of iterations with a parameter, so let's do it. As you remember, parameters must be declared before everything else, so I want to call this parameter radius because it's going to be the radius of how many pixels we are going to sample. And we're going to use these as our condition, so it must be less than radius, and then we're going to divide this by radius. Very well. So if now I modify the radius parameter, you can see that the image gets blurred on the x-axis. Let's actually go above 10, and that's how it looks like. It's being blurred on the x-axis. Because for the single pixel that we get as an output, we are basically summing. Now imagine that this toggle is my pixel. We are summing all the values from, let's say, 6 pixels, and we are summing them all together, and then we are dividing this by 6, and this is going to be the output for that pixels. So we are summing together all the pixels color, dividing it by 6 in order to have it in the range 0 to 1, and that's why it looks so blurred. So we made a little blur filter that works only on the x-axis though. Pretty cool. I want to stop here. This seems to be a lot of stuff already. So now you should be able to experiment with the for loops by yourself. So in the next video, we're going to complete our for loop to add another axis, so the y axis. So we're going to have not a mono-dimensional blur, but a 2-dimensional blur. Also, we're going to introduce functions which we will then use inside our for loop. So it's going to be pretty cool. For the moment, I hope this was clear enough. If you have questions, of course, you can write them in the comments, and also if you would put a like to the video, this would be great. And of course, you could also check my Patreon to check my shared patches and see what's going on there. Join my Discord channel, and I hope anyway to see you on the next video. So, have fun and see you soon. Ciao!